Hi, I'm Oludaramola. I'm the Associate Director of Machine Learning and Artificial Intelligence Enabled Cloud Technology Research Projects at the Optimal Mobile Solutions Consulting Group. I lead transformative ML and AI project initiatives that solve very challenging problems within different industries. I ensure that I aim for maximizing return on investments while driving scalable and reproducible product solutions. This week, I'll be sharing with you my most recent AI project for evaluating future home prices in Austin, Texas. Specifically, the problems I was hoping to solve were, does it make more sense now or near short term future to invest in single family real estate homes? And more importantly, can we use machine learning algorithms to help feel confident about these predictions and, most importantly, provide cost saving opportunities for end users? Let's get started. So the first thing that we want to do is ensure that we download the necessary libraries and making sure we take a look at our data set as far as historically, do we have all the information there? Are we looking at the appropriate time frames? And just taking a look at trends if possible before we actually go ahead with the algorithms. So import pandas, SPD, import numpy, MATLAB, stat models, sklearn, regression, mean squared, R squared. Now we're actually going to go ahead and take a look at the Austin 2022 through 2024 single family real estate data. This data is from July 1st, 2022 through August 1st, 2024. Now I'm just going to take a look at my data to ensure this data set is complete, and it looks like there's 24 rows. The columns are the date, the price, and because I'm gonna also do a 2080 test, I've also created copies of the original price so that it can be ingested. So next I'm just going to take a look at the first 4 rows of the data set. We can see that we have our date. Our first entry is from July 1st, 2022 with the price point of $1.01 million. And we see August, September, October, November 2022. Now we're just going to take a look at the tail of the data set. We're only working with 2 features, as you can see, date and price. And what the goal would be is to predict future prices. So we're going to want to use the date as an indicator, and then the price that we want to predict for, which will be in the future. Next, I just do some descriptive statistics of the column. For instance, the high, average, and low over the last 26 months. So the highest price over the last 26 months in Austin single family was 1.011 million. The lowest price was $717,013. Now I just want to take a look at the complete data set. quick observation, it seems like the data has a negative relationship with the date. So for example, as we proceed on with the months, it appears that the prices are decreasing in Austin for single family homes. Again, we're just going to do some summary statistics just to feel more confident of the information that we previously reviewed. So highest price 1.011 million. Lowest price was $717,013, and the average over the last 26 months is $841,398.23. Again, it's just very, very important to ensure that your data is clean. I always make sure that, when I'm managing my teams, in addition to do any analysis as far as confidence, just ensure that you're able to concretely validate and make sure that you're not going to have to do any rework. So we've been able to do that twice here now. So now we're actually going to get into the supervised learning models, specifically linear regression for predicting future prices for single family homes based off our data set. Before I do that, I'm just going to plot this data just to see if I can see any trends visually. So what I'm plotting is the historical single family prices from 2022 through 2024. As we can see, starting in July 2022, my gut was accurate in the sense that the prices seem to be decreasing. So over the next couple months, it's just decreasing, all the way through currently July 2024. So now I'm actually going to do my future predictions. Specifically, I want to understand short term over the next 3 months, 6 months, 12 months, whether or not using machine learning and supervised learning model linear regression, will there be an opportunity for a cost savings, or should I go ahead and make a purchase now? Looking at the trends, it seems like there could be a cost saving opportunity if I were to wait to make an investment purchase. However, I'll need to actually compute that to feel even more confident and ensure that is the case. So I'm going to go ahead and do that now. So what I'm doing is, again, importing the necessary libraries. We're going to go ahead and ensure that from a mean squared error and R squared, we feel confident. I feel confident about what I'm reporting out, and most importantly, what I base to make my investment decisions on. So I'm going to train my data set. I'm going to make sure that I apply 20/80 split, if I remember correctly, and just make sure that everything looks great based off my R squared and other indicators and values I'll take a look at and share with you. So here's the data set. Regression, training the data, splitting the data, training my models. This is what I'm going to predict. So the 5 dates that I want to predict for this use case that I'm reporting out to you is for November 1st, 2024, January 1st, 2025, March 1st, 2025, June 1st, 2025, and then November 1st, 2025. The only caveat with this and doing this predictions is as we proceed on with time, for example, by January 1st, we will have historical data from the last 5 months to improve the model upon. And given we don't have that information now, what the model is going to do is use our historical data set, the 26 values over the last 2.5+ years, to model and predict what the future prices will be for single family homes in Austin, Texas. And then after I predict the future prices, I'm also going to print out the OLS regression results to determine with high confidence or not whether or not I need to tweak my model and reprogram it. Lastly, I want to see the linear regression equation. This is helpful for being able to predict any future date, and that's what I'm going to do. So using the historical data set, machine learning arrived at future prices in November 2024. The predicted price will be $645,603. In January of 2025, predicted price will be $620,212. And in March 1st, 2025, future predicted price for a single family home in Austin, Texas is $595,653.67. So now that I've been able to predict and demonstrate to you, the question that I would ask myself is how confident, how good of a model is this, and do I need to perhaps tweak my parameters to improve the model? So taking a look at the OLS results, um, the R squared is 0.97 and the adjusted R squared is 0.969. What this R squared indicates is that, from a, let me highlight R squared, which is 0.97, and the dependent variable being price. 97% of the model explains pretty much all the variability in the real estate prices over time for this data set. So we can feel pretty confident that, I feel pretty confident that this is a good model for predicting future prices in Austin, single family home in Texas, based off the machine learning model that I just demonstrated to you. And even furthermore, if we take a look at the F statistic, both in the model as well as the individual predictors, the date original, what we can see is that they're both statistically significant with very low p-values, which indicates very strong evidence that the date original does affect prices. So I can keep going as far as additional readouts from the OLS regression results, but I feel like the two biggest thing as far as the dependent variable, which is price, which we can see here, and then the R squared, which is also here, in addition to the adjusted R squared, which is also down here, tells us that, you know, how single home prices, again, I just want to reinforce this, there is a relationship, and as we can see, that information can be explained by the variable price. Again, it's a very simple linear regression model that is very powerful in the sense that if I'm making an investment decision now, and historically looking at this data set, I see that prices are going down, I'm able to predict future prices, and I can see the cost saving opportunities here that would be available for me, right? So instead of spending, for instance, the most recent value is a little over 700,000. It seems like if I were to wait a little bit, there could be a cost saving opportunities that could be significant. So same thing here, you know, continuing with the AI ML project. What I wanted to do was kind of predict the price for November 1st, 2024, and visually see that. So for November, just take a look at this. Right, so we want to look at November 1st, 2024. We want to see the predicted price using historical data set. And this is what our supervised learning machine model is arriving at. So we're looking at, in November 1st, $648,353 predicted price for a single family home in Austin, Texas, based off our historical data set that we used to compute, and I just illustrated above. Now I'm going to do the same function. Now I want to take a look at January 1st, 2025 to see what the predicted price will be. And the predicted price for January 1st, 2025 will be $623,451.43 using the linear regression model. Last illustration use case for future predictions. I want to take a look at March 1st, 2025. Just want to determine how much of a cost saving opportunity there could be if I were to wait even longer for purchasing a single family home in Austin, Texas. So the predicted price for March 1st, 2025 is $559,365 based off the historical prices that we've looked at starting in August 2022 in a linear regression machine learning model. What I did here was just take a look at the historical data points and fit the linear regression model on that historical data point. I wanted to just take a look at that and make sure that as far as historical data sets, I've already demonstrated the future predictions and fit the regression line there. So now what I want to do is just take a look historically at the old data set and then just fit that independent of the future predictions. So this is the fitted linear regression line visually for the historical data set. So here are the actual prices in blue, as we can see, and then I fit the linear regression line here. This line is just to take a look at the data again. More visualizations. So what I did with this last prediction and regression visualization was to predict all the future use cases. So for instance, November 1st, January 1st, 2025, March 1st, 2025, etc., just to give the complete picture of what that would look like to the rest of the project team and our end users. So we can see here the historical prices in blue, the regression line, and then the predicted prices for September 2024, for November 2024, January 2025, March, and I even went as far out as November 2025 as well. And we can take a look at those predictions one more time. Up here. So prediction for November 1st, 2024, all the way through November 1st, 2025. And again, I would encourage the team to, and I would also just keep evaluating our data set as new historical prices are published. So for instance, in October, November, December of 2024, once those data points are evaluated, we can then I can then update my model. Right now, these are future predictions based off a historical data set that I have and have applied linear regression, supervised learning machine models. So to conclude, what I've been able to demonstrate is AI insights from historical data sets. I was able to do that using linear regression models and feel very, very confident based on the R squared and R scored that this data set and my prediction models are a good one. My adjusted R squared were in the high 90s. Similarly with the R squared. F statistics, same thing. I think all of the data points that I just presented all indicated and suggested that this is a great model, given all the variables and all the results that the OLS results showed. So this right here. The biggest takeaway in summarizing this data AI report for single family homes in Austin, Texas would be, what is the cost savings, right? I just did all this, and why does this matter? How can this help you, or how can this help me? Well, two things. From a reproducibility, we can see that this model explains the variance for our data set, right? And that's something that we can feel confident about, and we can keep improving upon as we get additional data sets as we work towards the future. So for instance, right now, we don't have the information for October and November, and what I can do is use machine learning and AI to help inform my decision making. So if I know that future prices are predicted with high confidence to be this much, I may just wait on purchasing a home, right? Single family in Austin. For instance, if I wait even longer until next year, this model is indicating that there could be additional cost saving opportunities. So that's kind of how I would interpret and I would take action on this. And to kind of quantify what those cost savings opportunities are, let's actually compute it. So let's bring out the calculator and see how much cost savings we were able to generate, I was able to provide as a result of this project. So for a single family buyer or investor looking to make investments now, what I was able to compute and what we can see is that over the last 26 months, the average price is $841,398.23. Now, if I know that the predicted price in November is going to be $645,603, what's that cost saving, right? So, 841,398. Just going to subtract future of 645, 603. So $195,795 cost savings difference from the current price, which is the average, and the future predicted price of what a single family home in Austin is predicted to be based off AI, machine learning, linear regression, and supervised models, right? I just demonstrated that. I just walked you through that. And that's just for November. Now, if we take a look at, for instance, January and March, there will be even additional more higher cost savings because prices are predicted to be even lower, right? So that's kind of how you can, and how I think from a decision-making perspective, this information in this project could add value. And let's just take a look at January and March just to see what those cost savings numbers are. So we can take the average. So if we, again, taking the average last 26 months, and then we wait until January, we have a cost saving opportunity of $221,186 based off this linear regression model, just for one single family investor looking to make a purchase in Austin, Texas. Now, someone might tell me, well, you're doing the average. What about, just use the lowest price, the most recent price instead of the average? All right, well, the cost savings won't be as much, but there is still a cost savings. So if we do the most recent data point that we had, 717,000. And then we just subtract that by the future price of November. The cost saving is $71,410, right? So I just demonstrated that the future predicted price based off this linear regression model for single family in Austin, if you were to wait till November 1st, you could save yourself $71,410 in investing in a single family home. So that kind of concludes, in summary, the many value added that I was able to produce for this one project, Austin Single Family Homes. I hope you've enjoyed these AI insights, and if you really enjoyed it, feel free to hit that subscribe button so you get notified when I publish new insights every week. My name is Olu, and it's been a pleasure kind of walking you through my most recent studies and findings, and I hope you have a great rest of your day. Talk soon. Peace. Love.